Okay. Hey, team. Goodness gracious. Good morning. Happy Sunday. Happy Easter to those who celebrate. I am just gonna make sure. I'm gonna closing tabs and things. Okay. Awesome. So, um, yeah, good morning. Sorry, I poured my coffee. I haven't drank my coffee. I pretty much rolled out of bed, put on my favorite unicorn hoodie, and now I'm hanging out with you, which is why I don't have a backdrop up because I did not give myself enough time to do that and start this stream on time. But what I'm very excited about, okay, I really want someone to explain to me what in the world it means when someone talks about like humans like raising your frequency or inner like the kind of like new age woo woo stuff, right? Because it does not make sense to me. And when they talk, I don't understand it. So I want someone to explain this to me. And I think I found some videos that's going to explain it to me. So, but I'm a little concerned. I'm a little concerned that we're just going to use the word quantum like the word like atomic or nuclear was used in like 50s sci-fi, you know? Cause that was like, "Oh, it's fine, it's just the radiation, and that means magic," you know? So, I'm pretty sure that's pretty sure that's what this is gonna be, but I really hope someone can try to explain this to me, because, like I said, it doesn't make sense when people try to talk about, like, raising your frequency. I don't know what that means, because, like, you can calculate, like can you calculate a frequency? You can calculate a wavelength for a human. Yeah, exactly, Tesla Ranger. It's what's the thing that's oscillating. So if you really, really, really wanted to, you could calculate a like black body radiation frequency. I guess that would be you. I guess you could do that. You could calculate a black body radiation um, uh, wavelength and frequency for like EM radiation being emitted if you really, really wanted to. Um, oh, hey Ben, how are you? Um, And but that is just a function of, like, temperature. So but they mean it as like a anyway, it doesn't make sense to me. And that brings us to these videos that I found. Here we go. It's a playlist, but each one's like 15-minute. Some one's 15 minutes, then the rest are like 7-ish, you know? So we'll see how many we get through today, um, uh, and see what happens. Okay. So one, I just want to talk really briefly about like what is quantum physics, you know, because I feel like people are going to get it wrong. Quantum physics is just like the physics of small things, you know? Um like when we're getting down to individual like electrons or even subatomic particles, so we're dealing with like quarks and other subatomic particles. Quarks, bosons, the theoretical like graviton, you know, like so fundamentally what it is quantum physics looks at the very 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 small scale of the universe, um uh at the very 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 small scale of the universe, um things start being discretized, right? So we don't like if I were to take a voltmeter and measure the like current and voltage and amps coming out of my like electrical socket, right? That tells me like voltage. It doesn't tell me like individual electrons. But when we get really 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 small, we're starting to think about like an individual electron and the amount of charge that that guy has, right? So that's the idea of something being quantized. So quantized or discretized would just be pretty much synonyms. And at the very small scale of the universe, it looks like everything ends up quantized, right? Everything ends up as a particle. So we have a particle that gives things mass. We have, um, you're right, Star Runner. Current is in amps. Um, Listen, I'm working on my coffee. um, yeah. No, I'm teasing. It's always fine. I want you guys to correct me when I say silly things. Okay. Uh, so everything becomes quantized, right? So that's fundamentally all it is. Now, do individual particles, can they sometimes behave in really weird ways? Sure, right? That's what you get with like the double and single slit experiments. We get quantum tunneling, which is particles can like teleport, apparently. That's how your thumb drive works, by the way, if anybody still uses thumb drives. Um, Two particles can be separated by a large distance and still affect each other like instantaneously. That's super weird. So there's weird behavior at these scales. But fundamentally, what quantum physics is just like, turns out it looks like we can kind of simplify all fundamental properties of matter down to like individual particles. Um, so that's kind of it. It's not like a catch-all for everything, you know? Unlike what Star Trek would have us believe. Or any other science fiction. Ant-Man does it too, right? We're going to the quantum realm, and that's where crazy things can happen. You know, it's as nonsensical as Bruce Banner turned into the Hulk because of gamma radiation. No, he would have just died. Um, Anywho, okay, so let me make myself little and let's check out the first video in this. We've got a handful of people watching. I know it's kind of early on a Sunday, especially depending on what time zone you're in. But I appreciate you guys being here so much. Okay, we'll do this one. Law of attraction explained by quantum physics, part 1. Oh, and if you guys don't know what the law of attraction is, that's just the like what you put out into the universe comes back to you. So if you want to be successful, you just have to tell the universe that. It's very new agey, and I'm not a big fan of it.
Tuesday, what do you want to do tonight?
Same thing we do every night, Pinky. Try to take over the world.
Hi, I'm Greg Kuhn. Today I'm reading from my popular book, Why Quantum Physicists Create More Abundance. Who among us hasn't been entranced by the promises made by the law of attraction?
Yeah, someone, Eric, you made a really, really, really good point. That law of attraction does deeply remind me of the prosperity gospel, which I'm a little obsessed with. I found a whole book that was like someone's PhD dissertation on the history of prosperity gospel in the United States, and it's a little creepy how like much it is part of our culture. That book is called Blessed. It's by Kate Bowler. She's a PhD out of North Carolina's like divinity school. Uh Anyway, I was a little obsessed. And Star Runner, I'm so glad you like the early morning streams. This is going a little bit easier for me on my schedule than doing evening streams because like all of my evenings are getting eaten up. Um and I like to, pay attention to my husband sometimes and stuff. So, okay. But Pinky and the Brain, he is dating himself a bit. However, I do love Pinky and the Brain. I think that's a spectacular cartoon. We might have to speed up the how fast this guy talks though. Let's put him on let's not normal. Let's put him on 1.25 and see if that's okay.
I assume you have, considering you're reading this book. Me too. To hear that you can attract the things you desire into your life is an amazing premise, and it most likely jibes with your intuition about how life works. After all, our culture is replete with homilies, parables, and metaphors that teach and reinforce the idea that we are the source of our material experiences.
None of which are like viable evidence, right? Anecdotes are fine, anecdotes are not evidence. So I you know, everybody's heard a story that's like, I said to a friend, you know, I just said to the void that I wanted to make more money, and then a week later I got a raise, right? That's all that's doing is when you've primed yourself to see a cause and effect that's not there, right? And it also, humans aren't great at seeing when things don't connect, right? Um, so that's how psychics work, you know. You only remember the things they get right. You tend to not remember the things they get wrong. And I forget, there's a word for that and I forget what it is. Uh, but yeah, I hate to break it to everybody, but like the book The Secret lied to you. You can't, like, putting good things out to the universe doesn't mean only good things will happen to you. The universe is cold and unfeeling.
When you realize there is nothing lacking, the whole world belongs to you. You reap what you sow. What we continually think about eventually will manifest in our lives. Be careful what you wish for. You just might get it. What comes around goes around. You get what you give. Treat others as you would have them treat you. The heart that gives gathers. Whatever your mind can conceive and believe, it can achieve. Who wouldn't want to wave a magic wand and make her desires manifest? Who wouldn't want a personal genie to grant her wishes? And since the law of attraction more or less proposes these possibilities, who wouldn't be interested in using it to achieve her dreams and desires? Yet for so many, using the law of attraction to fulfill their dreams and desires remains as elusive as those dreams and desires themselves. I'm always hearing from readers who feel they must be doing something wrong, or more commonly, that the law of attraction lacks a clear set of instructions for its full and proper utilization. I empathize with these frustrations. So I've created this book to show you that the law of attraction is very real and available to you right now. The law of attraction is not mystical or esoteric. Through the
Yes, it
incredible
is.
modern science of quantum physics, we now understand just how our material world is created. And
No, we don't. We actually don't. Sorry, like quantum physics is great, but like, honey, we don't know that much, right? Like the universe is deeply mysterious, and we know very little about it as human beings. So the main thing that I want to point out where like this gets, listen, like having a positive attitude, you know, that's a great thing. Treating others the way you want to be treated, like these are just sort of like things, you know, general platitudes, basic advice on how to like not be an asshole, you know. Um and you know, that's all well and good, but the problem here, which is to me like is very much secular prosperity gospel, is the idea that now what it means is that if bad things happen to me, it is my fault, right? If something bad happens to me, it's because I put negative energy out into the universe or I manifested negative things. So the like Christian fundamentalist version of that would be um the fundamentalist version of that would be if I had enough faith, then bad things wouldn't happen to me. So if a bad thing happens to me, then it must be my fault, right? And that's really, 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 really toxic. Whether that's coming from like that's just a toxic thing, no matter where it's coming from. I definitely saw that more growing up in a more like even in an evangelical, like that was a mindset that I kind of didn't like that I saw in a lot of evangelicalism growing up. Um, uh, anyway, but yeah, John F. McDropout, you're definitely right. This is about like trying to find a way to control things that are outside of our control. Um, yeah. Dan, I like that. If you've never solved a Schrodinger equation, or if you don't know what the Schrodinger equation is, let's not talk about quantum mechanics. Like, let's start there. If you don't know what that is, you don't know what quantum mechanics is. I hate to break it to you. Our friend over here on YouTube using some lovely models of what's that, lithium? Yeah, we got some lithium on the screen here.
guess what? Quantum physics shows us that you create your material world,
You sure
just
don't.
as the law of attraction promises.
How does
I hope
this
that
work?
as you learn what quantum physics has to say about how you create your material world, your inspiration and motivation to use the law of attraction is bolstered and fortified. I believe you will find that inspiration here and be able to finally use the law of attraction just as you always hoped you'd be able to. In this book, I will remove the mysterious veil from the law of attraction and teach you in plain, simple, everyday language how you are creating your material world right now. It has been my experience, and an experience shared by thousands of readers, that once you understand the science of deliberate creation, your use of the law of attraction is injected with rocket fuel. And as you are about to learn, quantum physics releases that elusive genie you've always been searching for and allows you to begin aligning your material world with your desires as you've always hoped.
Doesn't this feel really predatory and gross? Sorry, I know we haven't gotten to any science yet, but like this is pinging all of my cultometer. This is pinging my cultometer that is very, very, very finely tuned. This feels really culty and gross to me, and I'm not a fan. Because I'm gonna be the one that gives you control over your life. I don't like it. I don't like it. Anyway, okay, sorry.
Quantum physics is the most accurate and reliable body of science ever created. Its accuracy tests to hundredths of a decimal point. Famous physicists
Sorry, its accuracy tests to hundreds of a decimal point. I should hope so. I should hope all science has that type of precision. And also, what does that mean? That's like what does it mean to say that like quarks exist? Because that's part of quantum physics. Like quarks exist. That's just a statement that's true. What does that mean, my friend? Hundreds. Exactly, Dan. Hundreds. And like this, it's the most blah blah blah. I don't know. I don't know by what metric he's measuring that. The most precise or the most accurate or whatever. Because quantum physics doesn't explain large scale gravity, right? We have yet to find that unifying explanation of like unifying physics, right? Where one thing can explain both the like quantum scale and the large scale of stars and planets and universes, galaxies, maybe universes. I don't know. As far as we know, we only have one. Okay. Uh, yeah. Goodness gracious.
and author Brian Greene tells us that it is difficult to imagine we will ever come any closer to understanding precisely how our universe operates than through quantum physics. The story
Yeah, sure. Like it's a great, great, great tool. That doesn't mean we already know how it works and like I okay, let's keep going.
of quantum physics starts with the first scientific revolution, which gave the world an immense set of rules describing how the universe works, and finally resolved most of the mysteries of it, or so we thought. The science created by the first scientific revolution came to be known as classical physics. The first scientific revolution began in the 16th century and featured such names as Galileo, Kepler, Copernicus, and Newton. We're all familiar with today's one name only stars like Madonna, Bono, and Oprah. Well, these men were some of the original stars with one name only status. So immense were the discoveries these men made during the first scientific revolution that we still learn about them in our high school science classes. In fact,
So yes, but let's be very clear that this is talking about the rules of the physical world. You know what physics is not actually good at explaining at all? Um uh Human behavior or the behavior of any individual. Like physics isn't going to explain why, or like physics can't predict what your dog is going to do today, you know. um so it's good at like things that aren't alive, and then it also is good at explaining, like if you really want to get technical, right? Like chemistry is just applied physics and biology is applied chemistry. And there's an XKCD cartoon that's that. Um, but like the rules of the universe, that's not like he's already over applying it, right? He's already over applying physics because again, physics is real bad, is a terrible tool to use if you're a sociologist, you know, or a psychiatrist or a psychologist, right? Or anything that has to do with like human behavior. Physics isn't good at that. And quantum physics isn't going to explain that. In my opinion, I don't think it ever will. There certainly are people that think that if we can, it's kind of the clockwork universe thing. Like if you can just understand how all physical particles are going to move at all times, and you know the starting point, then you'll be able to predict literally everything that's ever happened. Whether or not you think like there's no evidence one way or the other. So whether or not you think that is kind of a it's a matter of opinion, and so you're kind of free to think whatever you like on that because again there's no evidence one way or the other. But this guy here, you are creators here with quantum physics proves the law of attraction, definitely seems to think that like I as a human, if I just understand exactly all of the laws of the physical laws of the universe, then I'll be able to manipulate the universe to my will. And that's not real. That's not real at all. Ah, hey, Alias Fake Name. Thanks for joining.
By the end of the 19th century, most scientists believed that the scientific revolution had everything figured out. In 1875, for example, when famous physicist Max Planck was deciding on a discipline of study, he was liberally encouraged to go into mathematics because, quote, all the interesting work in physics has been done. The first scientific revolution was so powerful it ultimately influenced every aspect of the industrialized Western world. The philosophers, sociologists, psychologists, physicians, politicians, artists, writers, and other visionaries of modern Western society used the classical physics of the first scientific revolution to create and construct everything we know about our social, organizational, and personal paradigms.
I'm gonna need a citation on that. Because, like, pretty sure the Impressionists weren't super concerned with physics. You know, pretty sure. Oh gosh, what is it? That was that really kind of odd style of art. Cubism. Yeah, cubism. Cubism is super weird. And Chaz, super glad you made it. Welcome. Okay, so he's definitely like way overstating the point here, in my opinion. Um, way overstating the case. Physics is great, and yes, like you need a good understanding of physics to like build a bridge, right? But please explain to me like how I don't know FDR used physics when when he was developing the New Deal. Like economics isn't driven by physics; those are very different fields.
If you live in an industrialized Western country, you live in a society that bases almost all its knowledge of the material world and how we operate within it upon classical physics. Consider what life was like prior to the first scientific revolution. People believed, among other things, that the Earth was stationary and the sun revolved around it. A bizarre idea by today's standards.
Did we? Because we've known that like the Earth is round and not the center of the universe. That's been discovered by several people several times. So, did we believe that, friend? Did we?
They believed that your blood didn't circulate through your body, that all matter was made of one of four elements: fire, water, earth, or air, and that the best way to ward off colds was to wrap urine-soaked hose around their necks. I could go on and on.
But here's the thing, the work of Newton didn't fix any of that. The work of Newton didn't change any of that. If you want to talk about like the scientific method, that was a thing that like once applied to medicine, like that we like improved our understanding of medicine and the human body by leaps and bounds. But this idea that like no, this is all the classical physics explains literally all of it. Like no, it's not like these three guys waved a magic wand and then the whole world changed. You know, that's not how science works, right? And then oh gosh, okay. Yeah, yeah. Chaz, I hope I'm pronouncing your name right. I like your tree frog, but Allah vaguely understood applied poorly. Absolutely. And Tesla, I didn't realize I always pronounced it Planck. Um, um, so if I'm wrong, I'm very sorry. I always thought it was Max Planck. Anywho, okay. All right, let's keep going.
listing more ideas that make Renaissance era humans seem like cavemen when
No,
compared to modern man. And if you think those beliefs were held only by the common, uneducated people, think again. Even the select educated few believed that anything studied outside of law, theology, medicine, or the arts was magic, and that academic studies of one of those four fields should involve observation alone. Renaissance era thinkers believed that a real scientist followed Aristotle's method of inductive reasoning and never conducted experiments. It all sounds quite crazy by our modern standards, doesn't it? You certainly don't have to be a scientist to know all those beliefs and practices are way off the mark. The average Joe off the street in the 21st century laughs at all these ridiculous notions. But the reason we laugh is not because we're inherently smarter than our Renaissance era ancestors. We're definitely much better educated, but we're not born with bigger and better brains than our predecessors. We know those ideas are off base because of the paradigm changes that occurred after the first scientific revolution.
so I don't like the way he's phrasing this because it's not like paradigm changes. This is because I think it's really easy to look back at like what was the understanding of the average person of how the universe worked in 1502 versus 2022, and see that there's a huge difference and think that there must have been a leap, right? When really it's small incremental change. Um, it was, germ theory. How long did it take for germ theory to be accepted? A very long time. Science changes, like, science changes slowly. We change our minds slowly. And so it's not really like a paradigm shift. It was Newton was able to describe the behavior of some basic objects. Um, uh, and then that he also helps develop calculus. And then those tools were applied to more and more complex systems. And I bet you're right. There are people who still don't accept germ theory. There's people who still think the Earth is flat, um, and that we only have existed for 6,000 years. And all of that is equally silly. Um, so he's painting this as, we used to think like this and now we think like this, uh, and as though that was a jump, right? When in reality it was the work of hundreds and thousands and hundreds of thousands of individuals, all slowly but surely adding to our collective knowledge. Now, he is right. I do like that he said that we as modern people are not inherently smarter than people who came before us. We just have access to more information. We are better educated. Other people, we don't have to redevelop calculus because other people did that for us. Um, okay.
It is hard for us to imagine what difficulty and courage it would have taken the average European to digest and believe the earth-shattering discoveries coming from the first scientific revolution. Even though these findings were true and could be proven through experimentation and mathematical formulas, early adopters risked their very lives in latching onto these beliefs. The science of the first scientific revolution, classical physics, did eventually change the Western world's paradigms, though. In classical physics, the universe, or any material object in it, is seen as a huge machine with a set of intricately interacting parts like the inside of an old-fashioned clock. Each part of this machine has only a few simple properties and movements that are determined by two things: the part's mass and the forces acting upon the part.
Sorry, he's saying that like Newton's understanding of gravity is the entirety of classical physics. Um and that's not true. Classical physics like includes some basic E&M. It includes like a lot of like waves and vibration. Like it includes a lot more than just gravity. Um uh so not quite, my friend. So for example, all of meteorology, all of fluid dynamics, right, which is what I think about every day, does not use we don't use quantum physics, team. The only place where it might come close is when we're considering how heat from the sun is gonna like work. You can consider you got to kind of consider the wavelengths, but you don't need quantum physics. Like you just need the classical understanding of um EM radiation as a wave, right? If you understand its wavelength, you're going to understand how that light's going to scatter through the atmosphere. So like all of our understanding of incredibly complex, beautiful systems like tornadoes, hurricanes, snowstorms, just how the everyday atmosphere works, you don't need any quantum, right? That's all classical physics. Again, quantum is only going to matter once we're getting down to really, really, really fine scale. So part of the thinking of classical mechanics is a little bit of that clockwork universe. But you can actually break the clockwork universe idea with math. You don't need quantum because you can get systems that behave perfectly well under classical physics that are chaotic, which means um, that breaks the idea of the clockwork, right? That breaks the idea that you're going to be able to predict it out into the future. Um, yeah, and absolutely. Thank you, Silver Harlow. Thermodynamics. That's classical mechanics. Fluid dynamics, right? That's what I talk about. Electromagnetism. All of this is all classical mechanics. So like, you need a lot more than just a particle's mass, right? You need a lot more than that. So yeah, so he clearly doesn't even have a good understanding of what classical mechanics is. I think he might think that like what Silverhawk, you're totally right. Clockwork Universe broke at the three body problem. Goodness gracious, team, is a three body problem incredibly hard and not gonna work. I think this guy thinks that like classical mechanics is like physics one. Like I think that's what he thinks classical mechanics is, and then everything after that is quantum. Um, that's the only thing that makes sense.
Classical physics worked perfectly until 1887, that is. That year, Albert Michelson and Edward Morley conducted an experiment to calculate the speed at which the Earth traveled through space, or the universal ether, as it was called at the time. Classical
So the universal ether. At the time, people thought that all waves had to travel through a medium, right? Sound waves have to travel through like a fluid, right? So all waves in theory would have to travel through a medium. Light is clearly able to travel through space and apparently able to travel through a vacuum. And in reality, light, electromagnetic waves, can travel through a vacuum, but they're unique in that. Asterisks on that unique, well, but for a kind of base level understanding, EM waves are pretty unique in their ability to travel through a vacuum. But in like the late 1800s, people didn't think that was possible. So there must be something, a material that makes up the whole universe, and they called that the ether. Um, anyhow,
physics told them that since half the year the Earth was moving toward the sun, and the other half it was moving away, the speed of the sun's rays should have varied accordingly with respect to the position of the observer as he traveled closer and further away. Michelson and Morley spent a full year taking measurements, and the speed they calculated that the Earth was traveling was 0 miles per hour, which of course couldn't have been true. Houston, we have a problem. The Michelson and Morley experiment is now referred to as the most famous failed experiment of all time because it ushered into existence the science of quantum physics and the start of the second scientific revolution. Scientists wanting to explain the results of those experiments, or that experiment, discovered that classical physics could not be applied accurately to those parts of our universe that can't be seen with the naked eye.
Okay, it's not just that it can't be seen with the naked eye, because I can't see a red blood cell with my naked eye, and classical physics causes that to behave just the same. I think I'm actually not familiar with that specific experiment, but I'm guessing what they were running into is that the speed of light is a non-reference frame dependent constant, so they would always measure the speed of light to be the same thing. So that's not a great way to measure like motion of the Earth. I'm thinking, and so speed of light being a non-reference frame dependent constant, that gets us to special relativity, right? That gets us to relativity. I hate to break it to you, friends, but relativity isn't quantum. Those are actually different things. Um, Special relativity definitely doesn't need quantum. Uh, you can get to special relativity just as like consequences of classical mechanics. It starts to get real weird and definitely feels like we're breaking away from classical mechanics. So, like Newtonian gravitational stuff, absolutely, we're moving away from that. But you don't need quantum to get to it. You don't need to track the behavior of, I think, still to this day, theoretical gravitons. We don't need to track that to get to special relativity. I have had a class on special relativity. I have not had a class on general relativity. So I'm only vaguely familiar with general relativity. Um, so I'm not really comfortable speaking on that broadly. But speed of light being a non-reference frame dependent constant gets us to relativity, uh, not quantum. Okay. Um, And also, there's 23 people watching right now. Thank you guys so much. That makes me very happy to be hanging out with you guys. I was worried that like it would just be 5 of us here this morning. Um okay, Silver Harlow, thank you. Here, I'll put your comment up there. That experiment tested the hypothesis that light would move at different speeds depending on which direction the experiment apparatus bound to Earth was moving. And like everything else behaves that way. Surely light would too. But light is really weird. Um, Ooh, Chaz, that's amazing. A training manual for World War II radio tech that includes an overview of the ether. That's spectacular. I didn't realize that was still like, uh, still. I didn't realize that that was held on to that late. I thought we gave that up in the 1800s, or at worst, like the early 1900s. And Ben, the video we're listening to said 1887. Um, so I mean, hopefully he got that right. You know, hopefully that was a thing he can cite correctly. Okay. Um. Okay. So let's keep playing.
And you may not know all about this revolution yet, but that's only because the great thinkers of the 21st century have only begun to apply its discoveries to every aspect of our culture, as was done earlier by Locke, Smith, Marx, Darwin, Freud, Taylor, etc., after the first scientific revolution. But make no mistake, similar paradigm changes are coming.
Do you like that he just lumped Darwin into effectively classical mechanics? Like that was biology. That was something completely different. Goodness gracious.
Classical physics is still an accurate and appropriate science to use with the material world that's visible with the naked eye. But when we examine the very tiny and the very large world, we need a different science to understand its properties.
Yes, but quantum doesn't explain to the very large. And Ben, yeah, absolutely. I think that's the point. Is that uh, uh, we didn't at that time. We did not know light was a non-reference frame dependent constant. So their assumption was very reasonable, and they didn't immediately understand why it didn't work. You know, because that jump to, oh, therefore light must be the same speed no matter how you measure it. Like, huh, it's really weird. Because that's it cannot be overstated how weird a conclusion that is. Because again, light is the only thing in the universe that we know of that behaves that way. It's weird.
That science is quantum physics, and it has changed almost all the rules. Quantum physics is strange and bizarre in that it violates our long-held beliefs about how the world functions. So it's tempting to dismiss it as nonsense, but dismiss it at your peril, because quantum physics has proven to be one of the most successful physical theories ever created. The basic features of quantum physics are: 1. Living matter, or material reality, is made up of organic or unified wholes that are often greater than the sum of their parts.
What does that mean? And also, no, not everything's organic. Geez, organic means made of carbon. Let's calm down. Dude, you learned that in high school chemistry. Like everybody knows that's what organic means. Gosh. Okay. Silver Hollow, I think that is Maxwell. I think that was Maxwell. Um, I think he's just referencing that first experiment as well, I don't know. It doesn't matter. That'd be a fun. Maybe we should do some science history streams. That would be really fun. That would just require a lot of research on me.
This concept is called holism, and it is the polar opposite of the machine metaphor of classical physics. 2, there is
What's holism? Because I've literally never heard of that ever. Okay.
not necessarily a relationship between cause and effect. Action is not always caused by another force exerting itself. 3, the observer
Yeah, so there are some places where like there are some places where in quantum physics, specifically if we're looking at these specifically if we're looking at the quantum scale, cause and effect breaks down. However, comma, that doesn't translate up, if that makes sense. Like that, and so cause and effect specifically in the sense of Newtonian physics. For every action, there's an equal and opposite reaction. I think that's what he's talking about here, but I'll have to get at it. Oh, and is holism philosophy, not science? It's almost like those are different fields. Jeez.
and the observed cannot be separated. The observer's observation and expectations become literally a part of what is being observed.
Okay, so let's be careful with this. The idea that like the observer is able to change the state of a particle. Because to me, this is something that's often misunderstood. And that is okay. Double slit experiment, right? That's typically the one where we start to talk about the like observer changing the behavior. The double slit experiment is going to happen exactly as predicted, right? Without the observer, no matter how many human eyeballs are looking at it, right? Me as a human with eyeballs observing this experiment does not change its behavior. If we use a specific tool to measure things, right, and use that to make an observation, right? Because in science, we often use observations to mean measurements, right? And I think that that has translated poorly outside of the science world. So if we use the right instrument to observe the particle, to measure it, and that's a stage, we measure that as a certain stage of the double slit experiment, then that changes the behavior of the experiment. This is because that observation is not passive. It actually takes action upon the particle. So to be very clear, observer in the sense of observations change reality, observer does not mean human eyeballs, right? That doesn't mean passive observation. It means something is interacting. Um, and by the way, in the side chat, we got Silver Hollow giving us a great explanation of holism. So considering everything together as a whole, a favorite of woo paddlers, but also Buddhism and Taoism. Excellent. And he's using holism. It's the opposite of reductionism. Okay, that's cool. I think I'm gonna, because we're not really watching a video, I think I'm gonna keep my face big. It's a little bit easier. Okay, let's keep listening.
In fact, the observer and the observed may be said to be two different perspectives of the same thing.
Yeah, sorry, that's always true. If you think about it, right? If you as an observer are watching me do something, we're both experiencing the same event from different perspectives. I hate to break it to you, friend, but that's not that is not groundbreaking ideas.
4. Linear systems are not linear. They are equations whose effects are not proportional to their causes.
That's a fun sentence. Okay. He just said that no system is linear. So that's not true. Linear systems exist. It's also true that in a nonlinear system, I don't know, things are more complicated in nonlinear systems, but this like the effect exceeds is like greater than the cause. Like that's very silly. That makes no that like that's trying to take a big concept and simplify it down to something that sounds deep and meaningful, but like no. No, something being nonlinear just means the math is a lot harder, like, to explain it. Like, all of fluid dynamics is nonlinear, and that's why it's hard. Like, there's a whole different like, you approach nonlinear systems mathematically very different than the way you approach linear systems, um, uh, but I would never start to philosophize about what that means for cause and effect. Like, that seems very silly. There we go. I don't know. Batman's been missing streams, guys. So I got him fully in frame there. And if you can see, I've also got a bobblehead Obi-Wan Kenobi there. There. That's a stuffed animal of a blue-footed booby. That and that's a silly robot children's toy I made. Okay. Okay. Let's
There is a lack of logical sequence, correlation, and cohesion found in the universe where we once thought that everything was neatly and logically ordered.
no. No. There's not like things can be related in a logical way or a cohesive way and we still get bonkers results because that's kind of the mathematical nature of nonlinear systems. um but I guess it is like the universe is more complicated than we used to think. That's um yeah. Yeah.
Don't quite know how to make sense of this information? You're not alone. I can't yet give you a list of household names who've created new paradigms from the concepts of quantum physics. That is because the second scientific revolution is only a century or so old, and the findings from it have not yet permeated our culture in the manner that classical physics had.
But you could take a class on quantum physics, buddy. There's free classes on this. I know MIT has its quantum physics class up on the interwebs for free. ocw.mit.edu, search for 804. Anyway.
But they will. Books such as those in my Why Quantum Physicists series are contributing to a change in belief systems that reflect this new, more accurate picture of our world.
You're not contributing to scientific discussion, friend. You're contributing to woo. And this is very silly because you're neither a philosopher nor a physicist. And you're conflating all of them together. And this is very bad.
Because of quantum physics, our understanding of societal, cultural, social, and personal structures, rules, and dynamics are already changing. 20th century physicists such as Max Planck, Niels Bohr, Werner Heisenberg, Erwin Schrödinger, and Albert Einstein have uncovered truths about our world just as paradigm-shattering as those of Copernicus, Galileo, Kepler, and Newton before them. We now understand that our universe is fundamentally different than we ever imagined, and can prove this through quantum experiments and formulas. As you learn about the concepts of quantum physics...
All right, we're going to cut off his outro on this, like, end of that chapter. Let's go to the next section. Let me know if the audio jacks up. It should be fine.
2 times richer than Jeff Bezos? It's true.
Same thing we do every night, Pinky. Try to take over the world.
Hi, this is Greg Kuhn. Today, I'm reading from my popular...
Ben, you're right. I don't have a Robin. I should get a Robin. I got this friend when I was in high school, and we got to go to Six Flags Over Texas, where they have all of the Batman rides. And I bought him for myself, and he is giant, and I love him, and he has traveled with me everywhere since then. But you're right, I do need a Robin to go with him. I'll have to maybe I should go to Six Flags. Okay. All right. We're going to get to talk about the double slit experiment. I'm excited.
Soon see why it holds such mystery and beauty for them, and also why it teaches you everything you need to know about the very real science of creating reality.
I'm real sus of that claim,
Here is the
friend.
double slit experiment in a nutshell. A physicist places a particle cannon in a stimulus-free chamber that is aimed at a wall with 2 slits in it. The particle cannon fires particles, electrons. Behind the first wall is a second wall, on which is recorded the electrons' final landing spots, after they pass through the 2 slits. The cannon fires electrons at the first wall like a machine gun, shooting electrons in a rapid stream. If a machine gun were fired at a wall with 2 slits, you would expect that the bullets would produce a pattern of bullet holes on the second wall corresponding to the diameters of the 2 slits on the first wall. In other words, it's logical to assume that the 2 bullets would form an outline of the 2 slits on the second wall. You would be correct, the electrons in the double slit experiment, to hit the first wall and not make it through the 2 slits. But since most of the electrons do make it through one of the 2 slits and land on the second wall, they should form 2 roughly rectangular patterns, a slightly larger outline of each slit. But they don't. The electrons form waves on the second wall.
Yeah, so this is a really, really famous experiment, right? It demonstrates particle wave duality, which is really cool. So electrons, just like photons, electrons can behave as either a particle or a wave. And what we're seeing here is we started treating them like a particle, but turns out they're behaving like a wave on the other side. And so my like 30-second explanation for that is so this is the our part, is an electron a particle or a wave? The answer is like yes. They can so yes, the answer to that is yes, they're both a particle and a wave. When you're down at the quantum level, pretty much everything can behave as both a particle and a wave. If you want to know like which one is it, the answer is both yes and neither. Oh, hey, Dapper, welcome. What'd you miss? A gross misunderstanding of classical mechanics. Gross misunderstanding of what nonlinear means. And now he's going to explain the double slit experiment to us poorly. So he's explaining this pretty well. And Silver Hollow, you're absolutely right. Feynman did a lot of really important work, but you don't just want to quote the dude. Anyway, okay, so we're getting, oh my goodness, we're getting wave-like behavior out of an electron. Very cool, right? A very important experiment. But let's see what our friend's conclusion here is.
It's as if the electrons change from particles into waves after they pass through the 2 slits in the first wall. How do they do that?
Okay, so no, right? Because they were always both a particle and a wave, right? Or in reality, they're probably some higher, like existing in some higher dimension, right? So there's some higher dimensional object that, like, depending on our perspective here and our limited understanding of the universe, our limited ability to perceive the universe, we can either look at it as a particle or a wave, but in reality, it's this like more complicated thing. Isaac Asimov explains this in terms of stick figures in a traffic cone, and it's really great. I like that explanation a lot. Yes, all particles are waves. Okay.
You'll find that answer to this question solves the mystery of creating reality.
Does
How
it?
could the electrons, shot out of a particle cannon in a stimulus-free environment, land all across the second wall in wave patterns?
Because they're both
To
particles
answer this
and waves.
question, physicists arrange a photon emitter to fire 1 photon at each electron as it travels out of the particle cannon toward the 2 slits. The interaction between the photon and the electron changes the results to what classical physics would lead you to expect. When an electron collides with a photon before passing through the 2 slits, the electron hits the second wall in the logical pattern you thought you'd see the first time. The electrons behave as you expect, forming 2 roughly rectangular patterns, a slightly larger outline of each slit. Here is why the double slit experiment dispels the mystery behind the science of creating reality. The experiment shows us that electrons exist as both a wave and a particle simultaneously until they are observed. Until they are observed,
You see, he says observed. And what he means is get smacked with a photon of sufficient energy, right? No, is that a form of observation? Sure, but it's not, again, human eyeballs looking at a thing, which is when you say observed, that's what most people hear.
electrons are neither wave nor particle. They merely represent the potential to be either one. Prior to observation,
No, it's more complicated than that. It's not that they can either be a particle or a wave. And like, no, it's a lot more that, again, they're both at the same time all the time. But if you, I don't know, the way I explained this to my enlisted physics students when I was in the Navy was if you ask if you ask an electron or a photon, if you ask it a particle question, it gives you a particle answer. If you ask it a wave question, it gives you a wave answer. So I explained that in terms of like, hey, you can take light and measure its wavelength and frequency and all of that jazz, and all of that stuff's going to be true. Or you can take it as the photon and you can measure its like momentum and the photon energy, and stuff like that. And all of these things are true at the same time. And again, that's because what the thing is actually more complicated than what we currently understand. Yeah, it's a thing that is more complicated than what we currently understand. And because of our own limitations in both understanding and because we exist in like a three-dimensional world, or we're able to perceive the world in 3 dimensions, we are limited in how we are able to perceive these objects, right? So really, yeah, Silverhall, that's a great way to say it. They're bilingual in answer in the language of a question. So if you're just shooting the electron and it doesn't interact with a photon for the double slit experiment, that is, for all intents and purposes of this analogy, a wave question. If you hit it with a photon, that's going to be of sufficient energy. Then that turns it into a particle question. So depending on what question you're asking, it gives you the answer in the language you expect, right?
the electrons are neither a wave nor a particle. They are literally both at the same time. When the electron struck or interacted with the photon was observed and thus took the form it was expected to take. Electrons,
Sorry. Yes, the electron observed it. Like, no, geez.
the building blocks of all matter, have no pre-existing state of being. Electrons don't exist as a wave or a particle when they're not being observed. When electrons aren't being observed, they exist in a state of pure potential to be either one.
Let's calm down. Keeping with it with a bilingual example. If a bilingual person is not actively speaking, then there's the potential that the next word out of their mouth will be in either language. That's not groundbreaking, right? That's it's this is really cool. The physics of this is actually really cool, right? However, when you try to philosophize it, right, it tends to get like the way this guy understands it is wrong, right? He's making it way deeper than way deeper than this really is. Things are complicated and cool.
Your observation manifests the electron.
No, my observation, my eyeballs did nothing. A photon of sufficient energy did something.
Literally create reality.
No.
And this experiment has been done over and over, always with the same results. Electrons are the basic building blocks of all matter.
Electrons are the basic building block, right? Electrons exist in atoms, but like electrons are made of stuff, right? They're not the basic building block. You can go smaller. Goodness, this is getting very wrong. I'm not very happy with him right now. So also this you control reality, you're able to affect reality, right? Let's be very clear about what was able to be affected in that experiment. Whether the electron appeared to us as a particle or a wave was able to be affected. You can't take that and extrapolate it out to, therefore, if I send positive vibes into the universe, I will receive positive, only good things will ever happen to me. Right? That's not, you can't make that jump. That's not real.
The stuff that forms every material object in our universe has no pre-existing state.
Electrons don't make up protons, friend. Okay.
Matter is not manifested until it is observed.
No!
As strange as...
That's not true at all. What? Matter is not manifested until it is observed? What does that mean? Right? So do you think that there exists like a lone proton zipping around space that nothing and no one has ever observed, right? That what do you mean? What do you mean that isn't manifested? Right? Like, jeez. What does that mean? That proton exists, right? This isn't some silly, like, if a tree falls in the forest, does it make a sound? And no one's there to hear it, does it make a sound? Like, if a proton is zipping around space and never has been observed, does it exist? Like, that proton exists. Jeez.
This sounds. You cannot say that electrons are particles that sometimes become waves, nor vice versa. Electrons are everything and nothing.
No.
Wave
what?
and...
No, they're not everything and nothing. They're a thing that exists that, depending on how you look at it, can look like a particle or it can look like a wave, but the thing still exists. It's still a thing, right? Ugh. Oh, okay. He's making me mad now because he's saying nonsense.
Particle at the same time until you or something else observes them.
No, not until I observe it, right? Basically, until it's asked a question, until we try to measure some part of it.
And or interacts with them. We've all heard the old metaphysical question. If a tree falls in the forest and no one is there, does it make a sound? The double slit experiment showed...
I brought that up sarcastically, friend. I have not heard of the website wisdom of Chopra. Will he explain how a human can raise their frequency to me? Oh, let's not assume gender. Will this website explain that to me? Because I'm very curious. Ah. Oh. Goodness. Okay.
Tells us that if no one is there, there is no forest.
If no one is there, there is no forest? What nonsense. No, honey, I hate to break it to you, but the forest existed well before humans, right? Goodness gracious. And again, it's not Nabila, I don't know if you're making a joke about, like, sing higher notes. Now that makes sense. Sorry. Sometimes when I get really frustrated, my voice jumps several octaves, and so I was concerned that I had done that. Excellent. Ooh, frequency changes. Okay, excellent. Frequency changes with the medium it travels in. That's absolutely true. So I guess if we go swimming, that would change our frequency. That would be fun. Okay. 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 This is humans don't have to observe matter for matter to exist. The universe doesn't actually care about humans. It is cold and unfeeling.
And the double slit experiment goes even further.
Oh,
It
does
shows
it?
us that it's not just the observation that manifests the electron, it's the expectation the observer holds.
I'm sorry, what? How is it the expectation? Second, please explain to me how the electron was manifested, right? The electron was there the whole time. It just changed its behavior because we sort of asked it a different question. Um, oh my goodness. So what if the physicist expects, like if the guy running the experiment expects a different result? I assure you, when the double slit experiment was first done, they did not expect the wave results on the other side. Jeez. Get yourself some Navy strength coffee there, Chaz. Like, please do. You need it. You need it to understand this. We need like that, that episode of Futurama when Fry drinks 100 cups of coffee and then is able to move faster than the speed of light. That is the amount of caffeine you need to get on this guy's to understand what this guy is saying.
Your observation, and more importantly, your expectations. You are creating the form matter takes. You are creating your reality every day through your observation of it.
I'm really
It's how
not.
the universe operates, and you couldn't stop it if you tried.
That's really not how it works.
If you're interested in the law of attraction, you've probably intuitively known that your expectations create your reality. Now,
No.
you have scientific proof.
No. Okay, we'll jump to the next video.
Hey, Blake, what do you want to do tonight?
The same thing we do every night, Pinky. Try to take over the world.
Hi, this is Greg Kuhn. Today I'll be reading from my popular book, Why Quantum Physicists Create More Abundance. This is Chapter 3, Combining the How and the Why of the Law of Attraction. Ready for some of the Law of Attraction's finishing scientific touches? Unlike the previous chapter, there is not one single experiment or scientist referenced here. Instead, I will cull various facts we've learned about our universe during the second scientific revolution of quantum physics. Although some of what you're about to read sounds like New Age philosophy or mysticism, make no mistake. This is all real, hard, verifiable science. Just like the confidence you have in the law
It sure isn't. Jeez.
of gravity. You know that when you jump up, you won't keep floating up, up, up into the stratosphere. You may soon have that same confidence in the science of the law of attraction.
No.
Every material object in our universe is formed from the quantum field. The quantum field is what physicists have named the measurable quantum soup from which you and everything else in our physical world are created. The quantum field is an invisible field of energy that represents all possibilities. It is everything and nothing all at once, and it holds the potential to.
I do not know what nonsense this is. I really do not know what nonsense this is. I'm really struggling with this concept. I think maybe he's talking about like things like, really, if you're looking at an atom, the electrons kind of exist in this cloud of potential, like there's the electron cloud. Uh it's basically, it's kind of the Heisenberg uncertainty principle. You can either know where something is or where it's going, but not both, when you're looking at individual particles. Okay. Yeah, and you're right, but that sounds a little bit like Feynman diagrams. So I don't know, because like in physics, the word potential means something very specific, right? That means like potential energy, right? It's the potential to do something. So you could talk about like, maybe you could talk about an electron cloud in that sense of it's just a state of probabilities, of potentialities of where the electrons might possibly be. Maybe. I don't know. I have no idea what quantum soup means. I do not know what that means.
Become anything and everything. You see, Every material object in our universe is comprised of the same 4 basic elements:
4.
hydrogen, oxygen, nitrogen, and carbon.
No. No, it's not. Not everything in the universe is made of those 4 things, right? For example, just hydrogen isn't made of those things. Uh, 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 stage 1 stars aren't made of those things. That's just hydrogen and maybe a little bit of helium. We've got some lithium in there. Oh my goodness. Also, that's not what the atmosphere is made of. The atmosphere is oxygen, nitrogen, and argon. And then other things fall out of that. Oh goodness. Okay. Yeah, helium, sulfur? No, not those things. Only hydrogen, oxygen, nitrogen, and carbon. That's the only thing. I think he said hydrogen. Let's back that up and listen to that again.
Same 4 basic elements: hydrogen, oxygen, nitrogen, and carbon. The only reason there are different material objects, i.e., your car is different from a candle, is that those 4 basic elements are combined differently.
Oh no. Oh no. Honey, honey, a car has iron in it. Like, no, there's a lot. Have you ever looked at a periodic table? There's other things, friend. What?
And are vibrating with different energy.
No! Oh no. Oh no. Listen, carbon, so vibrating with different energy at this level, at the level of a full atom, that tells you about temperature, right? Temperature is a measure of the average random kinetic energy of a substance. So vibrating with different energies at the atomic scale is temperature. Temperature doesn't turn a car into a candle or the other way around. Oh my goodness, honey. No.
About energy vibration shortly. It is important for you to understand that it is just as simple for the quantum field to create a human being as it is a pebble.
No. Is he talking about string theory with this quantum field? Listen, I don't know what he means by a quantum field, but that's not how elements come to exist. Uh So string theory, one of the basic things of string theory is this idea that there exist strings, which like size wise, like the earth is to an atom as an atom is to a string, right? Um, itty bitty, itty bitty things, and that these things in their vibration can create matter. That's not proven. That's not a thing that's known. That's a theory. But when it says create matter, like we're talking about subatomic particles. We're not talking about even a proton would be too complicated, right? We're talking about true fundamental particles. And Bent, I don't think he knows about fusion. I don't think he knows about that. Apparently, he doesn't know about iron either.
To the quantum field, there is no difference. It is just as simple for the quantum field to create a $1,000 bill as it is for the quantum field to create a penny.
No. What? No. How? Yeah, we've ventured deep into woo here, friend. Hmm.
The only difference between creating a $1,000 bill and a penny is the combination of those 4 basic elements and the speed at
But what about the copper?
which their energy is vibrating.
No.
Here's another thing you need to know about your creation of the material world. Every material object in the universe is nothing more than vibrating energy.
Nothing more than vibrating energy. Okay, I think where he's getting that from is the idea of matter being another way of storing energy, right? Like mass is a form of energy. We understand that as from E equals mc squared, right? I can store energy in mass and then I can revert that right back to energy. Um, uh, and so, in a sense, yes, we are all made of energy that is stored as mass and matter, right? Um, uh, and yes, all of that matter is vibrating because again, that has to do with temperature, right? There's a definition of absolute zero that is the temperature at which all particles cease to move, right? Like so cold that there's no motion, so there's no vibrations. But again, so like when I'm trying to see if I have like a hair tie around here somewhere because that's one of my favorite ways to explain vibrating like the vibratingness in a solid. But basically, hold on. Do I have a hair tie? Sure don't. Okay. Basically the idea is like in a solid, all of the atoms are fixed, right? But they're kind of like fixed in their structure, but they can vibrate back and forth. Whereas in a gas or a liquid, the particles are physically moving around. Okay. Cool. So we are vibrating it maybe technically correct there, maybe possibly. Sorry, I told you my voice gets high pitched when I get frustrated. Um okay.
For example, did you know that the energy inside of you right now is the equivalent of 30 atom bombs?
Is the equivalent of the 30 atom bombs. Oh my goodness. Um cool. Cool. No, I mean citation needed. Citation needed. On that one. Also, if we were able to convert all the energy, all of the mass of my body into energy, that would be a lot more than 30 atom bombs, right? Because there's a lot of mass in my body compared to, yeah, that's, oh goodness. That would be a lot, but we can't do that, you know? Um, to Bent and Dapper over there, I have a weirdly large range. However, comma, it does tend to skew lower. Uh, yeah. Oh, thank you, truth nerds. The mass deficit of the Hiroshima bomb was just about 0.75 grams. So think about converting a human to energy through it again. And by the way, that's a nuclear process. That's actually not the same thing as a quantum process. Um. Okay.
You and everything else in the physical world are just a glob of powerful, vibrating energy. And just as important, the vibrating energy of material objects is electromagnetic energy. That means the energy making up every material object acts as a magnet.
What? Everything. I'm a magnet, guys. I'm a magnet. Did you know that? I'm a magnet. So one, when I was talking about vibrational frequency, that's not electromagnetic energy. That is straight up kinetic energy, right? That is temperature. Okay. Goodness gracious. Okay. Second, if you want to think about electromagnetic energy, you would have to think about um black body radiation spectrum. So you can, if you really want to, calculate your black body radiation spectrum. But so you're emitting EM radiation. Technically, sure, yeah, absolutely. Um, um, Everything does. So, but that doesn't just because I am like the sun is not a magnet, right? Like emitting like light is not a magnet. That's still electromagnetic energy. So just become so to be a magnet, right? You have to exert a like electromagnetic force, right? And uh yeah, force and energy aren't the same thing, friend. Um I hate to break it to you. Anyway, and especially if we're thinking about EM radiation, right, which is what electromagnetic energy is, that has photons have no charge, right? So if you don't have a charge, you cannot exert electromagnetic force. Um, okay, cool. So no, we're not magnets. I hate to break it to you, friend. We are not.
magnetically attracting other like energy vibrations, and in turn being attracted by other like energy vibrations.
We sure aren't.
Matter in our physical world is constantly on the move, flying toward other like energy vibrations.
No.
As it is.
Matter in our world is constantly on the move. That is true. Flying towards other things of the same vibrational energy. No. No. In fact, if we're thinking that vibrational energy, remember that's temperature, right? That's kinetic energy. We know that nature abhors a vacuum. So if I have like something hot and something cold, right? Those then the heat is going to move over here. You'll actually move to the opposite, right? If I have hot, cold, heat's going to move towards the cold, not towards the other hot side. You're right, Dapper. The sun has a large electromagnetic force. Fine. It's not a magnet. Oh my goodness. Oh my goodness. This is very bad. I was suspicious that this was going to get bad, but it took us to the third video for me to have to stop every 30 seconds, every 5 seconds.
Attracted to them. Your expectations or subconscious thoughts are electromagnetic energy.
My expectations are electromagnetic energy. Citation needed, friend. What does that mean? I don't even know what to do with that because so thoughts, right? Thoughts are, as far as we know, um, electrical signals in the brain, right? So it is an electric signal. It's generally generated by chemicals moving. So a chemical potential causing a chemical concentration difference causing a chemical potential, which induces an electric charge. Um, but that's not the same. That's not the same thing as my thoughts being electric. No, thoughts are literally moving electrons. That's not the same as electromagnetic energy, right? Because that would be like moving photons, you know? So no, that's not what this is.
In fact, your expectations are some of the strongest energy vibrations in the universe. Imagine
Citation needed. Like, what does that mean? How do you know that?
holding a tuning fork and walking into the humongous Louisiana Superdome, where every seat contains a tuning fork tuned to its own unique pitch.
Why?
If you ring your tuning fork, every tuning fork in the Superdome tuned to a like pitch will begin to ring. That is how your thoughts operate in our universe.
Citation needed. So one, no, because that tuning fork example won't work, right? Because the tuning fork isn't loud enough. If I was very physically close to another tuning fork, and it doesn't have to be tuned close to it, it would actually need to be a harmonic frequency. So actually it would be if it's a C, if you were physically brought close to another tuning fork that was a C note, it would vibrate. But also if that other tuning fork was like the fifth on a piano, the fifth, which would be a G. So free, like the science of music is very, very cool. But thank you, Silver Hollow. That's a better way of explaining. Yeah, because I know it's the ions move around. Ions create a chemical. Like there's a difference of the chemical concentration across the barrier of a neuron that induces an electric charge in the neuron, which then fires, which then gets turned. That signal gets turned back into chemical potential. But I barely know anything about biology. right, but in reality, in that Superdome example, right, um, the sound of my tuning fork is going to be quickly dampened by the air, right, so that it's not actually gonna cause any other tuning forks to vibrate. So it's not a good analogy. Second, your brain is not a tuning fork, and that's not and sound waves, turns out, are different things than chemical potential in the brain. Right? Like, these are different things, and your thoughts certainly are not electromagnetic waves. That's not real life. Um, so Dapper brings up a fun quote here. Maddie doesn't know biology, but Claire Masters does. Guys, if you didn't know, Dapper and I and Bent, TD Lane, we're all really big tabletop role-playing game nerds. So I DM a Dungeons and Dragons 5th edition game every other Wednesday, Guns, Magic, and Steel over on Cheshire Vic's channel. It's delightful. Chesh is still her Tabaxi Rogue character has still been feeble-minded and is running amok as effectively a feral cat. But now the Wednesdays we don't play D&D, we're gonna start playing a Power Rangers TTRPG over on Dapper's Top Hats Off channel that Dapper's gonna GM, and I get to play in. And my character is Claire Masters. She's a biology student, and so she knows things about biology, even though Maddie does not. And yes, Dora, we are big old nerds. We're big old nerds, and like to talk about science and tabletop games. That's like my whole jam. That's my jam. Okay. Goodness, would I rather talk about Dungeons and Dragons right now than listen to this woo? Okay. Also, tuning forks don't attract each other. That like your analogy breaks down on so many places, my guy. Like just because I have my tuning fork at a C, um, all the other C tuning forks aren't just gonna like get like sucked to it. No. Okay.
Any expectation you hold resonates with other like vibrating things. That is not
No.
mysticism. That is the law of electromagnetic energy.
No, that is mysticism. That's not how EM radiation works. Please take a physics class. Once again, there's plenty of things free online. My favorite resource is OpenCourseWare at MIT.
Except your expectations don't just resonate with like energy vibrations, they also magnetically attract like energy vibrations or matter to
Prove it.
you. Your expectations are giant supermagnets that attract or create anything matching their energy vibration from the.
Okay, so no. Not only now are my thoughts magnets, my thoughts can also now create things, right? Like not just like bring like things towards me, but in fact cause them to come into existence. Um um please explain this to me. Please explain to me how, like, let's even grant the premise. Okay, thoughts are magnets. How do magnets make things? Please explain this to me. Um oh, John F. McDropout. Yeah. It's almost like we could come up with a testable hypothesis here. Goodness. Oh, but that's not how it works.
The limitless potential of the quantum field. The quantum field can effortlessly create anything at all, and it is your expectations
Prove it. Also define the quantum field.
that are commanding the quantum field to create your physical world.
No.
That is why many quantum physicists will tell you that there are as many universes as there are observers.
No. Oh, goodness gracious, no. 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 Yeah, Ben, that's a really great question. If thoughts are magnets, why don't MRIs mess with your head? That's a great question. That's an excellent question. One, I want to see that quote Like, where did you get that quote of there's as many universes as there are observers? Where does that come from? Please and thank you. Second, because I'm not even gonna like, I don't even know how to address that until I can get some context around it. You know what I mean? Um, but like, if we're gonna try to think that through, then that to me that sounds like some physicists being bad philosophers, you know? Because physicists sometimes they try to be philosophers and they're not, and so they're not very good at it. Unless is a rare occasion where somebody has like degrees in both, and then that unicorn, that unicorn can comment on both fields. But I'm not anyway. Okay, sorry, I'm rambling. Let's let this play.
It is important to note here that your expectations are not the same thing as your top-of-mind wishes and desires. Your true expectations exist on a subconscious level and arise automatically from your beliefs.
Okay, so that is a really great way to make this claim unverifiable. Because it's because how then do you control your expectations, right, in a measurable or consistent way if your expectations are not conscious thought? So it's my unconscious thought that drives this. So that's going to make it unverifiable because we can't control our unconscious thoughts. And so you can always say, well, I tried to manifest a pony and no pony showed up. Therefore, the law of attraction isn't real. That would say, well, your unconscious expectation wasn't for a pony. Right. So that makes this unverifiable. Can't disprove it. So that's yeah, exactly, Dapper. It's my true expectations and desires, not the ones I can tell you about, which is really convenient, right? That is a new age woo-woo way of saying like, oh, I prayed for X and X did not happen. That must mean you didn't have enough faith, right? It's the same thing. It's the same thing that makes something unverifiable. So that's bad and I don't like it.
This means that changing your expectations involves more than merely practicing positive affirmations or positive thinking. Your beliefs, upon close examination, may not actually be aligned with your desires. For example, you may desire more wealth, but hold deeply ingrained beliefs such as money is the root of all evil, or it is greedy to want more money, or people with lots of money are morally suspect and probably do bad things to get it. And those beliefs, or others like them, will always, without fail, subconsciously create expectations that will trump your conscious desires for more money.
More making this claim unverifiable.
In other words, no matter how often you play the lottery, if you have beliefs similar to the ones you just read, your subconscious expectations will command the quantum field to deliver a material reality that matches those beliefs.
Oh my goodness. Oh my goodness. Guys, my expectations, my unconscious expectations manifests as a losing lottery ticket. Causes my lottery a ticket to not be the winning one. Wow. 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 Oh my goodness. How is that supposed to work?
A law of attraction devotee, therefore, must make certain that she is changing her beliefs to match her desires. This, we now know, is the only certain way to influence the quantum field and intentionally create a more pleasing material reality.
Therefore, the good devout Christian must always be working to increase their faith. Yeah.
The good news is that your beliefs are subjective and can be replaced. The beliefs you currently hold were given to you by trusted sources. Most of your beliefs undoubtedly serve you very well. But in areas where your material reality is not aligned with your desires, your first priority must be to choose new, better feeling beliefs that are aligned with your absent dreams and desires. When you begin to do this, your expectations will naturally and automatically change as well, which will send new commands to the quantum field.
Please define the quantum field.
To learn more, look Greg Kuhn up on Amazon.com and browse through the many books that I have there. You're also
Well, we have to look at that now. Amazon.com. And what was his name? Greg Kuhn? Do you spell your name for me, friend? Uh, okay, I think maybe he spelled it Kuhn. Okay. Kuhn. Oh, I put a K in there. My bad. H. I know how to type. I know. No, stop auto correcting it now. Thank you. Okay. Grow a greater you. Why quantum physicists play Grow a Greater You. Learn how to live the most fulfilling life humanly possible. I think that's going to be the rest of that title. Do not fail. Why quantum physicists do not fail. Quantum physicists fail all the time. Learn the secrets of achieving almost anything your heart desires. Build new beliefs. How quantum physicists build new beliefs. He's really liking this. How quantum physicists do things. Create more abundance. Why quantum physics create more abundance. Physicists create more abundance. Goodness. Should we look at reviews? I like that idea, Dapper. So let's click on the first one. Let's click on these. What's up? If the law of attraction teaching has left you wanting more, read this. Ever wondered why you are unable to express a life full of abundance and fulfillment? Goodness. Cool. His process for resolving these blockages is sensible and easy to follow. Have you ever read a book so engrossing and so relevant that you placed your index finger on the words to follow along? This was that book for me. Mind Doc. Having read all of Greg Kuhn's previous works in the series, I'm pleased to write another positive review. Living in the new paradigm of the law of attraction. Oh my goodness. Oh my goodness. Can I find negative reviews? You're right. The reviews do read like an ad. Okay. I want to read. What did I do? Where did the reviews go? Several of them do say verified purchase, Dapper. Am I sharing this tab? Yes. Okay. Yeah, several of them say verified purchase. Here, I can make this bigger. I can make the Amazon tab bigger for you guys. There you go. I want to read the negative reviews. That's not helpful. Okay, I want to go to the 144 ratings. Let's find the 1-star rating. What do we got? Waste of time. The book was hard to follow. I'm glad I got it at the library. He made quantum physics harder to understand. Leave it up to Chopra to explain quantum physics. Just another Abraham bandwagon jumper. If you've read the teachings of Abraham, law of attraction material, don't bother with this. I wish you. Okay. Cool. What would we pay some of these reviewers? Some of those high-level reviewers? Maybe. Okay, what about the 2-star reviews? Lost my interest quickly, really difficult to get into. Aw, that's no fun. I want somebody to be like, "This is stupid." Thoroughly enjoyed his book, would recommend someone to purchase it, however, was quite disappointed when I got to the final chapter. Um, okay. Well, oh, good. Probably great for cynics. I disagree, friend. This was not great for me, and I don't believe any of this. Okay. Hey, team. How's it going? Um, goodness. Uh, yep, Silver Hollow. It's the if anything bad happens to you, it's your fault, victim blaming. So like, I wouldn't really care if like if somebody's like, I just want to put this out into the universe. I'm trying to do X, right? Like, um, I don't know, sometimes like that there's nothing harmful in that of like I'm going to state my goal and I'm going to say it over and over and over and over. That's going to help me be motivated. That's going to maybe alert people who like that's going to keep me focused on it. That's going to maybe like I'm going to tell people about this goal I'm trying to achieve so that if they can help me, like that I've put that earworm in their brain. Like sure, yeah, that sounds lovely. When I have a big goal, I definitely make sure to tell some people about it because then I have to do it. You know what I mean? But that's like motivational, you know? So if that's all this was talking about, like if that's all the law of attraction was, then I wouldn't give two poops about it. Um, but where it gets toxic is the therefore if bad things happen to you, it's your fault, right? Like that's where I'm like, no, 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 no. Bad things just happen. um again, the universe is cold and unfeeling. um okay. So, I'm gonna go ahead and wrap up. This was actually, I got to rant more than I thought I would. That was pretty fun for me. I hope you guys enjoyed it. Thank you so much for hanging out on a Sunday morning. All channel stuff. Okay. Um, I am actually gonna have time to film some Weather 101 vids this coming week. My general exam, I officially passed it, so I am officially all but dissertation and a doctoral candidate is my title. That also means I get a pay raise, which is great. Um, and um, that's really cool. I just realized that there's a form that I needed to get to the grad college, possibly by Monday. Anyway, um, so should get some Weather 101 videos up. Actually gonna have some time to film, do some stuff. I'm playing around with some other ideas for more content. Yes, Dapper, I do. I am celebrating Easter today, though not by going to church. I'm actually gonna go out and see some family. It's like a 2-hour drive to get to my aunt and uncle's house where we're meeting up for Easter lunch. So I couldn't go to church and do that and do this. So anyway, I'm really bad at shilling my channel, so I'm going to practice that here. If you are willing and able to financially support the channel, there's my buy me a coffee link down in the description. Otherwise, like, subscribe, comment, stuff like that helps the channel grow. All that happy stuff. I've got some like now that my channel's monetized, I've got some goals that the channel can pay for itself by the end of the year. Um, which just means I'm gonna try to make like $30 a month by the end of the year. That's the goal. Um, and yeah, I'm gonna be on Dapper Dino's channel on Tuesday to do some Matt with Maddie Young Earth Creationism debunking. And then Wednesday will be the premiere on Dapper's Top Hats Off channel of our Power Rangers game. So got that coming up. Happy Sunday, happy Easter to those who celebrate. I know it's also Passover and Ramadan. So if you celebrate either of those, appropriate well wishes for those. And otherwise, just happy Sunday. I hope you have a great day. You guys are lovely, and I will see you soon. Okay. Bye, team.